Hi guys, and welcome back to another video. Today we'll be resolving the issues that mainly plagued us in the last video and hopefully exploring a few new things. Stay tuned because it's going to be a good video.
So from further testing, we thought then it was a grounding issue. Moving some wires in a different place seemed to resolve the issue, but however, further testing indicated that this actually wasn't the case. So in the end, the final solution was that we found that a slightly different type of motor worked well. These motors are slightly more expensive than what are currently used, but if they work with the sensors, that's the price that we're going to have to pay to get the whole system working well together. At least now we've resolved that. That's one good thing sorted. And so we can now crack on with the rest of the project. Right, so back in the Fab Lab today, doing some laser cutting and 3D printing work. Hopefully this will be one of the final times that we're in here before we finish prototyping. So it's again 3D printing and laser cutting, some new components. So again, some good cinematics.
So given that we've now been able to resolve the motor and sensor issue by just replacing the motors, we've now been able to reattach all the sensors and everything back on with the gyro underneath there in its little rat's nest. And so yeah, all the sensors are back on and we can now focus more on some of the more complex testing.
Also, we've now got the PCB printed, so this should cut down on the number of wires we need to connect stuff with, hopefully making it a lot less complicated in terms of all the wires that are currently on the robot. Also, any other issues we might face in terms of power and all that should be resolved through the PCB, just because everything will hopefully have the right connection that it needs to and won't be interfering with any other connections. So the next thing to do, once this has all been finished up and the integrated chips put on it, is to then incorporate this into the final robot. As I said, this should clear up a lot of the wires and just make everything look a lot cleaner.
So following that testing from earlier, we're just doing some coordinates testing. So making sure that the coordinate from the robot is actually where it actually thinks it is. So just checking that on the laptop relative to hand measurements.
105, 103.
Is that right?
Yeah.
Nice.
So now we've finished with coordinate testing for today. The next thing to do is a bit of PID testing. So as you can see at the minute, it's rotating a lot and the error is massive. But this, as you'll see in a few minutes, is being improved.
So from doing some further tests, I've actually realised that the left wheel is hanging off really. I'm not sure if you can quite see that, but all the glue on the underside has come loose, and so the wheel is literally just hanging on by a thread. So that's kind of stopped progress for the minute in terms of rotating. Well, I was putting it on the floor and it wasn't turning, which was weird, I thought. I just thought the floor, which I'd been put it on, was a bit uneven. But no, the wheel has basically come off completely. So this is just going to go in for a bit of repair, and then hopefully later on today, we'll be back in business again. Right, so now this is fixed again. The left wheel is all fixed up, so we can start doing some more in detailed tests.
So from doing some further adjustment on the code, I've now got it to oscillate. This is good, showing that the system is underdamped. I'll go into that in a second. but then also reducing down the iteration time, I've got it to produce a much faster response, as you can see here. In terms of the different responses that you can get underdamped, critically damped, or an overdamped response. Ideally, you'd want a critically damped response, which has the shortest rise time and also no overshoot. So the aim of this process is to tune the PID controller with changing the values of P proportional, integral, and derivative side of things to prevent overshoot and to try to minimize the rise time as much as possible. As you can see here, I've just about done that. The overshoot has been reduced dramatically. Well, there is no overshoot, and also the rise time has decreased significantly. But again, there's still work to do on that.
Right guys, so that's it for today's video. I hope you've enjoyed it again. Make sure you stay tuned for the next video where I'll be using the 4 cameras to sensor the movement of the robot to validate that sort of thing, just as a pilot test. So be sure to watch out for that video next Monday, because it's sure to be a really informative and good video. I'll see you then. Don't forget to like and subscribe again.